you should be seeing my screen, which is TinkerCad. And TinkerCad is an awesome three-dimensional design program, but they've also included this new option for circuits. And I'll show you guys how to get there. So I'm just logging in with my Google, though you can log in however you wish. And on the dashboard, rather than doing the new design three-dimensional stuff, you go to the side here that says circuits. And then from there, we can see the library of circuits we've made or create a new circuit. As Lurch mentioned, this has all sorts of standard components. And these components can be brought into the platform, named. You can change certain things about them. And you can hold down Shift to highlight them and press backspace to delete them, or you can select them and hit the trash can to get rid of them. There's a number of different ones. We are not going to, so these are your basic components that can be involved in an Arduino project. If you go to all, there's a larger selection of items. And one thing that is useful is you can change how they are listed. So this gives you a more detailed description of what each of these components is supposed to do. And these represent real chips that you can buy. And so, of course, there's specification sheets on those chips. So it gives you a sense of really, what your library to work with is. It includes simulating Arduino, which is really awesome. And in the Arduino setup, it has many of the standard projects. In the event, I believe I put a link to the Arduino Learn Arduino basic book, the PDF of it. So that's a great place to start. And one of the first projects is going to be Blink. So I just dragged that over. It takes just a second, but you can see that there's wires, so there's nodes. Basically, you can wire things in by going to different ports and just extending out a wire between that and the and a component. I just hit escape because we don't need to do this, but this one has the pre-built one for Blink. Now, in addition to
Chia, one second. Why are you working in TinkerCAD and not Arduino itself?
Yeah, so because the Arduino itself, this is a simulator, so it's representing what you would do physically, which allows us to share it and practice for people who don't have a physical Arduino. So a good thing to do would be do it in the software here, and then once you have it working, because it might be quicker to do it in software, then you can do it physically on your Arduino, and you know that the setup is vetted. Where when
this is a virtual, so this is like a virtual test run.
It's exactly, it is a virtual
Arduino becomes, all right, sweet.
And if you got a real Arduino and put the resistor and the LED like this, it would do the same behavior when you turn it on. So the Arduino is two parts, the physical one, which is being simulated here, and then the code. So I just clicked the code button, and this is interesting. So typically when you're programming Arduino, you're working in wiring through the Arduino IDE. It will allow you to work in a code environment, but in this case, they're using this block system where you bring code in via dropping it in these little interlocking blocks that then have choices under those blocks. So you can define variables and other things. This is it's more intuitive perhaps to somebody who is newer to coding. And it could be faster for some very simple things. You can also see what that translates to as far as code. So this code should be more familiar to you as what you would see if you were writing in the Arduino IDE. So you see these translate. So high being turning on the pin, and to what pin you're writing it to, and so on. So these two are connected. If you start wanting to edit this code that's generated, you can do that. You can edit the text, but you then lose the blocks visualization. So once you leave the blocks, you are only editing code. So if I go to text, it'll say, are you sure the blocks won't work anymore? And now we're just code editing. And that's because you can do more with the code than you can do in the blocks. So it gives you freedom, but it has some limitations. So this is supposed to allow us to blink. I don't know why that little, there's a remnant on the page. All right, there we go. So I can do is I can start the simulation. And this is the same as just starting the Arduino or powering it up. In fact, does it change? Yeah, it shows it plugged in now rather than unplugged. And what do we have but a blinking LED light? So does anybody want to suggest how I might make this blink faster?
Change the time constant.
Yeah, so what's the time? Where's the time on it?
It says delay 1000. Just change it to like 250.
Yep. Oh, I have to stop the simulation. And 250.
Yeah.
And I'm going to start the simulation.
It'll blink faster now.
Yeah. So is it blinking faster or is it doing something else? Because as we walk through, it's turning on and it's high.
Okay, there's
for 250
time constants in there.
And then it goes low, which is equivalent to off, and it does it for 1,000. So really what we're doing now is we're just pulsing it, and then we're staying off. So
1,000 to 250 also.
Yes, if I wanted to make that more extreme, it's off for a while, pulse, off for a while, pulse. So that's the delay, or we can make it fast.
Now it's 50% duty cycle. Blink, 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 blink.
Yeah, and it's blinking quickly.
Yeah.
So we can see that it's the pin is assigned to 13. So that's the code there. And then we're digital writing and leaving. So I'm going to abandon this code. Well, so if we wanted to, we could download this code and then run it in Arduino. There's also a little debugging feature that helps you to walk step through your code. We don't have a bug right now, but we can do that.
Hey, question. Is this, can you run stuff besides C-based languages on this, or is it completely C-oriented?
Yeah, so this is, it's Arduino, which I think the language is called wiring.
Okay.
Is a subset, or is a bunch of functions within C. So it's limited specifically, I think, to just Arduino, the Arduino language.
It's surprising because the user interface. Look, my son has one of those. They're called like Servos. It's like a programmable robot, and look like the same programming language or the UI on top of it.
Yeah, absolutely. So this is based on something that's very popular, Scratch.
Okay.
And MIT put together Scratch, and then a lot of other programming languages, which are meant to be, or programming interfaces, which are meant for people to learn on, have adapted or adopted this. Another one is if you use the MIT App Inventor.
Okay.
I've used that for building like a small Android app, which is a lot of fun, and it uses a very similar puzzle piece lock and connect interface, which is for somebody new to it. It is definitely an easier way, and it gives you the logic.
Nice.
If I remember correctly, we can also go into a mode where we step through the different stages, although I'm not seeing it at this moment.
And just out of curiosity, is the environment completely isolated, or can you like use it to talk to other APIs or anything like that? Or
So as far as I know, it is isolated.
Okay.
It's primarily focused on learning and prototyping. It does have a couple of the features that you might like. For example, the serial monitor. So serial monitor is the data output to a computer. So it's what is the, you're often using a sensor and then you're feeding a computer for visualization or something. And so you would see those numbers come through on the serial communication or serial monitor. The other thing that it has, which is great, is it allows you to import libraries. So the way that you import a library, I see here that it's not letting me do it in this simple code editor, but I think if I go to text, yes. Okay, now this little file cabinet shows up, and there's a whole selection of libraries that I can add. So Neopixel, for example, would be a popular one for dealing with light strips. And so it includes the Adafruit library, which now gives you new instructions that you can implement on the device. As far as I know, you are limited to the list that they give here, which are the most common learning libraries. I did read a forum that said that some people were able just to like include the entire code of a library in the body of their sketch, which is not ideal, but in a pinch, if you have a library that's not too big, it may in fact be able to work that way. So let's just look at, just to jump ahead, why don't we just look at a Neopixel, and then I'll stop my like initial orientation and jump into, so I'll just highlight that by holding Shift, backspace to get rid of it. That should also clear the code, or it will warn me and say that one of the components that you're removing has included code. Is it not? I maybe have to select it and then. Oh, come on. Guess my computer's going a little slow. All right, there you go. Are you sure you're about to delete this programmable component? Yes. And so that now removes my code, and I can go back to the list. And I think one of the things that I'm excited about is these Neopixels. They also have lighting strips. So I'm actually going to go to, I'm not quite sure why circuit assemblies, there should be, wasn't there one that had one of those Neopixel lighting strips? I see a circle one. I'll bet it's, yeah. So they just haven't updated their icon. And so these are these very common strips that you find around. And what's awesome is that they're individually addressable LEDs, and you can do all kinds of fancy stuff with them. And if we go to look at the code, it looks like this goes right to the more complex code because it's out moved the more simple type that you can do in the blocks. But you see it's included the Adafruit. There's various instructions about where you are initializing the color assignments. And then it has some random assignment of values for the colors. And then it looks like it's moving through the different pixels. So let's just see what this does right out of the gate. Hide the code. And so it is picking a random color, and then it looks like it's sequentially walking through each of the LEDs and assigning it that color to the LED and going back through it. So this gives you an idea of something that's like pretty advanced for Arduino. And Jeffrey will definitely be interested in the ones, there's some motor controller ones in here. So the servo right here, and even analog read would be good because that's like or analog input. That's like using a pot or a potentiometer to be able to bring a value into the Arduino, and then you can
Hold on,
start.
which
connecting
ones?
it.
You said Servo and what's the other one?
Yeah, so Servos the output. So that's actually controlling a motor. Why don't we just pop that open right now so you can take a look at it?
All right, can you just go a little slow so I can take notes while you say this? While you do this?
Sure. Sure. Well, I am also recording it, which I'll make available.
Yeah. Okay. Cool.
So servo is a type of motor, and you can see here.
JR, before you get started, can you also, I don't know if this is going to affect the way that you work with this, but a lot of my motors are also using capacitors to store energy. So maybe like just keeping that in mind as we move forward.
Yeah, absolutely. Well, you could simulate that, the capacitors in here.
Okay.
It may not, it will have capacitors. It may not have all the types of capacitors. And it may be depending on the type of motor.
No, I mean, because I'm like,
yeah,
I'm working with the motors that I'm using are all wired up already and have their own capacitors. So I just was curious about like how that would work in conjunction with Arduino.
And this would be maybe a good time for me to turn it over to Lurch, who is more familiar with a lot of the technical aspects of these, motor controls and other things, or may or may not be. But I think what you'll end up doing is you'll end up looking at what the requirements of your motor are, and then you're going to have a control circuit. So you'll have your Arduino controlling that circuit, and then you'll be supplying the power, and you're going to be relaying that signal from the Arduino through a transistor. And so that transistor will be able to turn on and off the higher voltage signal, which can run your motor and is appropriately set up for your motor. But it will be using the lower voltage signal that comes from the Arduino. And so that, we'll get, well, I think it's a good time to sort of like let Lurch give me his impressions and his thoughts and questions, and because I've taken you as far as my competence allows. So Lurch, what are you thinking?
So I totally agree with you on that idea of controlling motors using some sort of switch, because the Arduino can't really support anything more than a ½ amp without resetting its own circuitry. So trying to power a motor that draws a lot of current and amperage will actually just cause the Arduino to reset itself. So what we have to do to get around that is the Arduino and the motors and the servos are controlled by 2 different power sources. And it looks like Rich is holding up a servo for us in the camera there.
Yeah, and the Arduino and the microbit will power this directly, because this little one doesn't draw much power. So if you got one, it's going to be okay. Like the way that circuit shows, it'll do that.
Yeah. Small servos. Yep, it'll spin, freely just fine. But actually, I ran into something like this in my own project where I had built an automatic cat feeder, and the cat feeder spun a servo with a paddle wheel to dispense dry cat food. And the weight, when I ran this servo project with no cat food in it, dry on the workbench, the motor would spin freely, no problem. But once I loaded the hopper full of cat food, there was too much weight on the paddle. And when the motor tried to spin, there was a lot of resistance, and all that power draw actually would reboot.
Yeah, that'll do it.
The Arduino. So a way how I got around it is by using a transistor.
Yeah.
And I forget off the top of my head if it's PNP or NPN. I get the 2 confused really easily.
I think it was an NPN the last time I looked.
Yeah, one draws up and the other draws down.
Yeah.
It depends which way you want to pull it. If you want to attach the switch to the ground line and pull, attach ground to the circuit, but then that means you have power on your circuit searching for ground, and anything that causes that ground will activate your circuit. Or you put it the other way around, and attach the power, your switch to the power side. So your circuit's always grounded and it's not applied to power until your switch flips on.
In the little project I'm working on with the microbit uses 4 of these guys, but the load is light because all it's going to do is be like an arm or a leg that's moving, and it won't move that much. That's 180 degrees it's turning. So I will only just have it move like 20 or 40 degrees, just a little bit. And so I don't think a piece of cardboard weight is going to be much of a load on it. But I can't run 4 of them on the microbit. I have to run it through a separate set of drivers. It gets a little tricky, actually, to do it. But nonetheless, we're on the right path, I can tell.
Mm-hmm.
So does that make sense, Jeffrey, about the bridging the control circuit and the powered side of it?
Not quite. I got a little bit lost somewhere. And
let me explain.
Would it help if I share an image of like what my wiring situation looks like?
Let me explain it. I can explain this. See, what the transistor does, it takes a little signal from the Arduino and it controls a transistor in exactly the same way that the little signal is changing. The transistor changes, only it changes a lot more current. So it's just a little single transistor amplifier that goes in, hook up to the servo. It's just an amplifier, and most of the time, I think in this case, to keep it simple, you'd probably use an NPN transistor and maybe 1 resistor, and then hook it up to the Arduino, and you'll be all set. So you can look up that circuit looks like. There's a lot of examples of it around.
Jeff, do you have a diagram of your circuit available, handy?
Yeah, let's do that.
Yeah.
Okay.
Is it on your computer?
Give me 1 second. I'll be right back.
Yeah.
And so just for folks that were interested, I'd really recommend there's the Getting Started with Arduino. And if you just look for it online, I found it in PDF pretty quickly, or you can support them and buy it. I use this to just go through and be disciplined and do several of the first projects, Blink, and then the other ones, even though they were simple. And it really did help me get a better grasp on Arduino. So I'd recommend that. And sometime, Lurch, maybe in your future hours, you could even go through each of the projects. I started with Blink, but then you can do the others, and that might be a way for folks to learn.
Sure, if there's a demand for it, that's something we can walk through together.
Yeah, absolutely. Go ahead, Jeffrey.
Okay. Let's see. No.
I guess looking up, can I display my ignorance here by trying to understand this concept? So
sure.
It sounds like an NPN transistor is like the equivalent of attaching a circuit to a light switch. So the idea is that you don't run the energy straight through the Arduino, but you are like buffering it by using the NPN. So it's like the switch is actually going to work, but you're triggering the switch.
So one way I would think of it is that you have a dam, and there's a big river with a lot of current, and there's a little tiny lever, and you can move that lever in order to close the gate on the big river, and it will stop everything, or you can move that lever the other way, and it will open the gate. And so you use just a little bit of energy, that's the control side, to change where the lever is, and that controls whether or not the flow of the big river is open or closed.
Okay.
And so this is, rather than water, this is done with electrons using a transistor, which just happens to have a special atomic property where that when you apply a little electricity, it will either stop or allow the major current to go through it. So you can use a tiny amount of electricity to switch on and off a big amount of electricity. And that's the premise of being able to have the two separate, a control circuit and a non-control circuit. So Jeffrey, go ahead.
Right. So on my screen, that's basically how the capacitor is wired to the motor and then to my electric source. And I guess where I'm getting sort of stuck is like where in this equation would the transistor and Arduino fit in? If that makes sense.
Yeah. My first question is this 120 volt? Is this AC power?
Yes.
Okay. So then we would certainly need to take a step up a little bit and go from something like an NPN transistor to a full-blown relay.
Down to a Triac, solid state switch.
Yep.
Triac. You would use the Triac would act like the transistor, only it'll do it for AC. So you think of the Triac as like an AC transistor, a small amount of change in current will control a large amount of 120 volt current. And a Triac would do it. You could use a mechanical relay, but it basically at that point it's either on or off. But with a Triac, it can be, brightness can change.
A solid state
think of it
allows
as
you to do kind of in between rather than discrete on or off.
Yeah, a Triac will control AC current. A small amount of AC current coming in will control a large amount, a higher voltage AC current going out. It's the same thing. It functions, you can think of it as a transistor, only it works with alternating current, where transistors operate with direct current, DC. So think of it that way. Triac would do it. You'd look up the circuit for it, and then you would be able to do that. But that circuit you're working at there, that's something totally different than what we've been talking about here. That's an AC operated device, AC operated servo.
But ultimately, you could use an Arduino, but you have to bridge it somehow because the way that type of electricity is very different. So, yeah.
Cool.
Yeah. Well, and I think I want to make sure that we've got a chance for like Arduino specific questions, but I'm sure that Lurch and Rich can help you puzzle through the specifics of how you get control to that AC circuit. But maybe first, I don't know if Jay or Tyler or Brenda or anyone had sort of questions specific to the Arduino and that Arduino controller system that I introduced as a simulator.
So actually, I have a couple of quick questions.
Yeah.
Well, the first one is, I mean, from what I understand, like the Pi, while it's not specifically Arduino specific, do they have a simulator like that for it, for like using the hats to try to control things, or?
Yeah, so just for folks that may not be familiar with Raspberry Pi versus Arduino, so a Raspberry Pi is a whole mini computer where an Arduino is just a small chip without all of the extra operating system or higher level operating system. But the Arduino, or the Raspberry Pi, sorry, has input-output pins on it. So you can control things much like you can control from an Arduino. They're GPIO pins.
Mm-hmm.
I am not aware of a Raspberry Pi simulator. That sounds like something that is out there. I know you can simulate the Raspberry Pi operating system in a virtual machine and play with it there. I just don't know that there's one where you can integrate virtual wires to virtual components and see them controlled in a simulator like this.
Okay, and that's really what I was wondering. And yeah. I really don't want to stay on that because I don't want to monopolize the time with it. The other thing is, because I'm looking at both of them, if I could get kind of like a walkthrough on what these numberings are on the board, kind of like I see you guys connecting things, but like I don't really know what these numbers are or what they're for. I just have a loose concept.
Yeah. Sorry, what numbers were they on the blocks?
Yeah, so the writing's on the board essentially. Like
Yeah.
the board's there, but there's writing on it, and no one's really gone over like what is written on the board, like beside all the inputs and outputs.
Yeah. Actually, Lurch, do you want to kind of take it on? Maybe you can share your screen and I'll start
Absolutely.
handing it off to you. Yeah.
I'm sorry. I was typing in the chat. Was there a specific question? Can you catch me up to speed? What was?
Yeah. So Jay was really interested on the board itself. So when you're looking at the Arduino and what's screen printed on the circuit board, and what do those numbers mean? So it's like
absolutely.
the pins are numbered and those sorts of things. So maybe you can pull one up and share your screen and
yeah,
flag whatever parts are interesting.
So let's see here. Whoa. One of these is our, okay, can you see my screen now?
Yep.
All right, excellent. Well, I guess there's a message at the bottom that tells me I'm sharing. That's good. All right, so the really neat thing about Arduino input and output pins, which are very similar to Raspberry Pi, so it's good that you brought up both because they both have these types of abilities, is these pins are input and output. So in the software, you can identify each pin individually and whether it should be, the Arduino should be talking on that pin, so it's outputting, or if it should be listening on that pin, so it's inputting. And so you kind of have to remember every pin can be input or output. And when we see a squiggly mark here, a tilde, that means it's a pulse width modulated PWM pin. So you can send anywhere, I think it's 0 to 255 off the top of my head. I don't remember exactly the pulse width modulation, but it's a range. And that's in contrast to the digital pins, which do not have tildes, which are just binary ones and zeros. So you can tell if that pin is on or off, high or low. And then anything with the tilde, you have that range where you could listen in for that range. On these bottom here, TX and RX, those are the serial monitor or the output of the serial pins. So you can kind of listen in on that serial port on these two pins. Or you can treat them as regular digital pins as 1 and 0.
So when you say listen in, what do you mean? Listen into what?
So you could have, when I say listen, I mean like let's say a variable resistor, a pot. And if you dial that pot left and right, you can change that dial certain positions. The Arduino can listen on that input and tell what position that variable resistor is at, because you can label that pin as input.
Ah.
And then on the other side of the board here, opposed to digital pins, we have analog pins, which is 0 volts to 5 volts. So on the other side of the board, you had digital pins, which are binary, 1 and 0. On the bottom side of the board, you could have voltage analog pins down here. And again, these are both inputs and outputs. So you could have any combination of these controlling a separate device like servos or motors or LEDs or what have you, or acting as input devices like some sort of button or dial or knob. And then we have some pins over here. These are all power pins labeled right here. Ground, there's 2 grounds side by side. The Arduino can output in 3.3 and 5 volts. I believe the power jack, if you use a barrel jack, it can support 10 to 15 volts, and the onboard voltage regulator will par that down for itself. But if you supply power directly to the pins here, I think you need to stay pretty close to 5. I think there's always a plus or minus. You can go a little bit above or a little bit below, but it should be as close to 5 volts as you can. So this is a 5 volt board. This big chip in the middle here, this rectangular chip, is the brain of the Arduino. It's an Atmega integrated circuit. Very popular. You can actually pull this chip out, and you can, the board and the chip are actually both open source projects. So you can get the schematic for these things, and you can build these components out of raw materials yourself. You don't really have to buy the Arduino board from the official company. They publish their schematics online for free, which is really amazing. But there's other kind of components on here, like capacitors and voltage regulators.
What are these refs? Are they? I mean, I'm assuming the references to something, the IO ref and the A ref.
The A ref, I think, yeah, they. I don't know off the top of my head what exactly the A ref pin is for. I imagine it's for measuring the difference between voltages.
Okay, thanks so much. I really appreciate it.
Oh, absolutely.
Hey, I have a picture of the driver for the servo. You want to see it? With the
Sure.
NPN transistor? All right, let me present it. Hold on a second. Find the right button to push here for presenting.
Okay. I think you're right. It says AREF means analog reference. This allows you to feed the analog a reference voltage from an external power supply, and then we can measure voltages with a maximum of 3.3 voltage. So it's related to measuring voltage.
So it's kind of like a voltmeter.
I think it's like it's a reference. So I don't know much more than that.
All right, so you see the output circuit there on your screen? I'm presenting. I hope everyone can see it.
Yes.
Okay, so if you look, there's a wire coming in on the left through a resistor into the base of that NPN transistor. And if you think about the middle part of that transistor is the P part. And that means that the signal coming from the Arduino is a positive going signal. And it goes into the junction of that transistor, and it turns that transistor on. Depending how strong that signal or how long that signal is there for, it does the same thing between and running the current through the top of the transistor and the bottom of the transistor. So the motor then gets the pulse or gets the current stronger because the top of that circuit has a different voltage source on it. And that source can handle a lot of power where the Arduino can't. So what you have going on in that NPN transistor is a small current controlling a large current through the motor. There's a couple extra devices on the motor. One of them is a diode in reverse. So what that happens, as soon as you shut the power off on the motor, the magnetic field on the motor collapses and generates a very high voltage. And so that little diode there will short the voltage out so that your circuitry does not get an electrical shock because the motor just shut off. The other little capacitor there is the motor itself is likely to generate little sparks and arcs as it's turning. And so the capacitor will short them out. The signals that come from those little sparks and arcs will just go right down and short them out. So you don't get a lot of noise, electrical noise coming back into your circuit. But there it is, a simple transistor, small current in, large current out. It's an NPN.
Can you drop this, Mike? Can you drop this inside the chat, please? The link to this.
Can I what?
Can you drop the link that you're presenting from in the chat, if you don't mind, please?
Now maybe I can, and maybe I can't. Let me tell you how I found it though. I went to Google and I just looked up servo control Arduino. And when it gave me a whole list of things, and then I switched to images, and I got about 1,000 pictures on the screen of images that are illustrating in some way controlling a servo motor from an Arduino. And I scrolled down through it. I found that one. I said, yeah, that one kind of addresses what we've been talking about. So if you do that, don't forget to use that images function on Google, because it's a survey of all the pictures on the internet that mention,
Oh yeah.
that mention Arduino and Servo. So that's what I did there. And that's two. Anyway, I'll leave you on your own there to figure it out. It's there. It's there. But the circuit is easy. NPN. So the P, the middle one, means that a positive going signal has to come into that transistor, and then it will control the large. And it doesn't have to be very much current. It's not a voltage controlled circuit. It's a current controlled. A small amount of current on that input will control a large amount of current through the collector and emitter all the way to the bottom there. So anyway, enough of that. Back to net control. Take it away, Mike.
Well, I'll reach out. Are there any other questions? In the last, couple minutes of the hour, we can try and answer any more FAQs or survey the crowd here.
I think all my questions are really pretty much taken care of. I have a lot I have to learn, so until I know enough to know what I don't know, then I won't have any more questions.
All right, thank you for joining.
Yeah, and is there interest in walking through projects or trying to do some of these Arduino projects virtually? Well, we're not able to, physically be together working on them with wires.
Yeah, I think so. I love to see what people actually. I mean, it's great to get the concepts behind it, but it'd be nice to see what crazy mechanisms people come up with these things. So.
Yeah, I was thinking about even doing like a challenge. Like we could maybe not a project that's pre-built, but say try and set this up. Pick one of the projects from the book that's not on the simulator, and then have people try and set it up themselves, and then come back to like one of these facilitator sessions and share it. So I think there's a couple of different things we might be able to do to have a little learning group. But those are ideas. But I submit that for you guys, and I guess Lurch, if you're done,
let me share my screen one more time.
Hmm?
I'm gonna share my screen one more time. Oh no, that's not what I want.
I was gonna ask after Jeff shows the screen. Would it be okay if I just heard what everybody's trying to build, just get some ideas of what I want to try out myself? So, and I'm sorry, is it Jeff or Jeffrey? I apologize.
Yeah. Oh, sorry,
Jeffrey.
I should have said Jeffrey.
Yeah.
Did I say Jeff?
Thanks, Foxy. Let's see.
Well, while he's getting that, one thing that I've built is it was based on the last project in the book, but I thought it was a lot of fun. Is I built a lamp that changed colors, like a mood lamp, and then I hooked that to a little app on your phone that I did in a phone app, and that sent information to a database. So it just had two buttons that said good and bad. And so you could be anywhere on your phone saying, good things happen, and the light would turn green or it turn red. So it's like the idea would be like your partner would have it at home and they would know whether you're having a good day or a bad day, just kind of passively by the light. It was just a, fun challenge. Yeah.
It looks like we're in a dungeon.
Yeah.
It's a kind of torture machine.
My life is a dungeon. Okay, so it's gonna be a little bit loud. So if you want, you could turn the volume now.
I don't know if we'll hear it though.
Oh, all right.
Oh, that's your servo there.
That's awesome. Okay.
Yeah,
this
and
is really
the concrete
this
block.
is really annoying, but sort of pay attention to this right here. That's my capacitor down there, and the motor is back here. And so essentially, what I'm trying to do is instead of having an on-off switch, and this was an earlier version. It used to be on wooden cleats. That was a really, really bad idea. And I've since welded metal cleats that are about a half of inch in thickness. And so the entire thing it's toggle bolted into the wall, and then hardware connects the cleat to the sculpture. So I don't get as much friction. But what I'm really getting at is instead of having to manually turn and off on. I think it would be so much smoother if somehow Arduino was worked into this, and this was able to pick up like some sort of sensor or sensory, either from like someone being near it or like triggering the sensor, and then that would cause the machine to run.
Let me ask you a question.
And that's essentially.
Is that a servo or is that just a motor?
Yeah.
So Jeff, was that just a motor that you're just turning on and off, or was it a servo?
That's a motor. That's a motor that's a rotary motor.
If you want to do that, let me tell you what's really easy. You could understand how an LED on and off, right?
Yeah.
Okay. There's a device called a solid state relay that has an LED in it. You can hook that up to your motor, plug it in the wall, and then your Arduino can just control that LED. When the LED is on, the motor switched on. And when the LED goes off, the motor switches off. So a small amount of current to drive an LED is all it takes to turn the solid state relay on and off. And that relay will switch AC power on and off. And it could be a huge amount of power. They come in different sizes. So that would be the easiest way to do it. You basically control an LED that's inside the solid state relay. It's a very easy circuit. They're inexpensive. And the nice thing about it, they're very safe. They have a lot of protection circuitry inside of them.
Was that the Triac, or what was that?
No, a Triac is a different circuit.
Okay.
A Triac, you can use a Triac too, but in this case, because this motor is either going to be on or off, it's not going halfway turned one way and halfway. It's not going back and forth. It's just on. Stop trying. So a solid state relay, look it up, SSR, and learn how to use it. It's just all you're going to do is control an LED inside the solid state relay, and hook up the rest of the solid state relay like it was a switch on a wall, and it will turn the power on and off. And it does it beautifully and smoothly and safely.
Cool. So I think we're, I don't want to stop people from continuing to ask questions, but I just will sort of end our formal part because we're at the end of the hour, and I'll stop the recording that we'll post. If there was a question from Tyler, if there's any sort of projects that people wanted to say, if you want to just say anything quick that you're working on that's cool, and then we'll end with that.
And you don't have to tell me your ideas either.
Well, I'm just and I know Rich is building a robot that's gonna like move and shake and respond according to input. So that's actually has some analogous things to Jeffrey. Great. So I'm going to stop the recording. So thanks everyone for participating.